The last section out of Unit 3 deals with covalent bonds and how to name covalent molecules. So we've mentioned before that atoms are most stable when their outermost electron shell is filled, right? That is, when their valence shell is filled. For ionic bonds, this involves gaining electrons or losing electrons to form ions, right? We physically gained or lost them. Okay, that we saw them leaving the valence shell or electrons gaining into the valence shell to form those ions. The ions have the same electron diagram as the closest noble gas, right? That we said that that's what their goal is. Well, atoms with 8 valence electrons are the most stable. So what we want to do here is instead of giving and taking electrons, covalent bonding is sharing electrons. Okay, so we're going to share electrons between nuclei to get 8 electrons in between them, a valence shell of 8. Okay. So a covalent bond is a chemical bond that results from sharing valence electrons, not giving and taking. A molecule is formed when 2 or more atoms bond covalently. So the term compound can describe ionic compounds. We can have covalent compounds, but specifically the term molecule is only referring to covalently bonded things. So things like water, right? We call them water molecules, but we don't call table salt sodium chloride molecules. Okay, we don't do that, right? So like NaCl is just an ionic compound. We can't call that a molecule, but water we can because it's covalent. So we share the shared electrons become part of both atoms' outermost shells. The covalent bonds form between non-metals. So we had ionic bonds that were between a metal and a non-metal, and then we've got covalent, okay, which is 2 non-metals. All right, so hopefully we can keep those straight. All right. Some elements never exist as simply a single atom. Okay, so when we're starting to look at the non-metal side of the table, things like hydrogen, nitrogen, oxygen, as elements, they don't exist as a single atom. So for instance, we don't have just like a random nitrogen atom floating around all by itself. We don't have a single oxygen atom floating around all by itself, okay? Because they're not stable. So to have actually elemental nitrogen, all right, what we have to have are 2 nitrogen atoms that are actually bonded to each other to form N2. So this is actually elemental nitrogen. Okay, it's something like 78% of the atmosphere is nitrogen gas, N2 like this. A single nitrogen atom by itself, what I had drawn before, would be not good. That would react very quickly with things around it. Same thing with oxygen. A single oxygen atom by itself would not be a good thing. Okay, we would need this to be bound to another oxygen to form O2. So all the oxygen that you are breathing in and processing and using to, perform all the biological processes in your body is O2. Okay, it's not just an oxygen atom. That would be pretty dangerous. All right. So the atoms that do this, or the elements that do this, they form what are called diatomic molecules. Di for 2, atomic meaning single atom here. Okay, this is because they want to fill their valence shells. So normally nitrogens in family 5A, it would have 5 valence electrons. Okay, it would want to try to react. Oxygens in family 6A has 6 valence electrons. It would try to react as a single atom. All right, so you need to know this list of the diatomic molecules: H2, N2, O2, F2, Cl2, Br2, and I2. How I tend to think of it is something like this. So we have hydrogen, which is its own little thing up here in the corner, and then starting here from nitrogen over to fluorine, down to iodine, back up, okay, and over. So I always think of it as like an upside down L Tetris piece here in the corner. And then we also have hydrogen, so you just have to remember that one's over here by itself. But if you're trying to remember which elements form diatomic molecules, I always think of it like it's an upside down Tetris piece and hydrogen up there. So 2 atom molecules are more stable than an individual atom. That's why these behave this way. So if you were in the honors chemistry class, they would get into a lot more detail with this than we will, and that's okay. But essentially, all right, what we're going to see happen here with like fluorine. Why does fluorine form a diatomic molecule? Well, it's got 7 valence electrons around one fluorine and 7 valence electrons around another fluorine. What it's going to do is each one of these is going to take one of its electrons and share it. So now, as far as getting the 8 electrons around it, 2 of them are shared between the fluorines. So hopefully you can see that there, right? We had 7 valence and 7 valence, so that's a total of 14. I still have 14 total electrons drawn in here, except that 2 of them are now being counted for both of these atoms, and that's how these covalent bonds form. That's why they form, and that's how we get that 8 electrons around it, right, to get it to that nearest noble gas configuration. Okay, and the second part of the video today is naming binary molecular compounds, so meaning 2 elements in these molecules. Okay, so we're going to look at an example involving N2O, and then we're going to let you guys try a few of them. So the rules like this, got 3 parts to it. Number 1, the first element in the formula is always named first using the entire element's name. All right, so we would name the entire thing here nitrogen. Okay. The second element in the formula is named using its root and the suffix "ide." Oxygen, changing, so we're taking the beginning part of it and changing the suffix to "ide," so oxide. Okay, and then we add the correct prefixes based on the number of each atom. So depending on what we have here, we're going to have to add in some kind of a prefix term. All right, so we're going to see what those terms are here in just a moment, and we'll complete this. So it's going to be something nitrogen, something oxide. Okay, so here are the prefixes that we are going to need to put in. And we'll talk about sometimes where you don't actually need to use it. There's one instance where we can drop a prefix. But the prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra. That's usually the one that I get the most mistakes on from students. They use like quad or something like that. But 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Okay, so we're going to use these to complete the example we started on the previous page, the N2O example. Okay, so using the rules, name the first element, nitrogen, second element plus the suffix "ide," so oxide. We have 2 nitrogens and 1 oxygen. Okay, so the prefix for 2 is di, the prefix for 1 is mono. All right, now in this case, right, it looks like it would be monoxide. All right, but we don't do that. We just drop that O there. We don't need 2 O's back to back. So this just becomes dinitrogen monoxide would be the name for N2O. All right. The one exception situation, let's look at this one. CO, naming the first element carbon, the second element plus the suffix "ide," oxide, so carbon oxide, and then putting in the prefixes. You might think that this would be monocarbon monoxide or monocarbon monoxide. But what happens is if the first element is 1, so if the first element is 1 atom, drop the prefix. Drop the prefix mono. All right. So in this instance, it's not called monocarbon monoxide. It's just carbon monoxide, which you've probably actually heard of, right? You probably have a carbon monoxide detector at your house. All right. So we just drop that first mono. Now we still include it for the second one. We always include it if the second element is just 1, and we still include mon in that instance, but not the first one. There are some examples of covalently bonded things that have common names. First of all, let's look at the names for these. NH3, if we were to name it according to these rules, would be nitrogen trihydride. Nitrogen trihydride. This has a common name of ammonia. Okay, you may have heard of ammonia before. Let's look at this second one. N2H4. This would be dinitrogen tetrahydride, based on its name there. This one's got a special name. This one is called hydrazine, which was at one point in time a type of rocket fuel. And the last example here, this would be nitrogen monoxide. It is often called nitric oxide, okay? And this is a vasodilator. Opens up blood vessels. Okay, so now that you've seen the naming and a couple of examples of it, go ahead and use the systematic naming to name these 5 binary molecules.